In this video we'll cover K-Cycles' new Ultra Temporal Denoiser and real-time playback feature with an updated render cameras supporting both Cycles and EEVEE. The powerful playback for single image or animation allows for instant loading animation image sequences, the impressive Ultra Temporal Denoiser for video stabilization and flicker removal can potentially save enormous amount of render time by using very low render samples. In addition, integrated with vector blur and K-Cycles PostFX or other Compositor PostFX add-ons. Optimize 3D viewport settings for playback, improvements in render camera to handle automatically multi-layer raw format animation sequences. All of this playback features playing in the viewport at real-time or near real-time speed. Let's set up the render settings needed for playback mode and Ultra Temporal Denoiser for Cycles. I loaded the scene 1 from iMesh. I use iMesh scenes for testing Ultra Temporal Denoiser, and these scenes are highly recommended, and there's an affiliate link if interested. For fast, high-quality, low-render samples, make sure to enable the Ultra Denoiser multipass option. The issue with low-render samples is that with denoising has flicker and turbo artifacts. That is where K-Cycles Ultra Temporal Denoiser is quite beneficial and can reduce dramatically the flicker and temporal artifactors. It can take much higher render samples with additional many hours and days without using the Ultra Temporal Denoiser. Preparing the render for K-Cycles Ultra Denoiser requires enabling the vector data pass and turning the compositor off. Done through passes data layer, and post-processing could be turned off here. In addition, the raw data needs the output to be a multi-layer exe. The recommended settings is half float and DWAA lousy compression. This will give you the lightest, more compact possible file. Having the least amount of data passes create a more compact and smaller EXR multilayer. Allow for real-time or near real-time playback in the viewport. Important is that each camera animation image sequence is saved in a separate subdirectory. Best is to use render camera feature. It has a new raw mode. Render cameras raw. So there's no need to enable the vector data pass or change the output to multi-layer. I can leave it to my final output, an MPEG, unless that is your final output and you want to keep it as a multi-layer final output. For this scene, my final output is going to be an MPEG-4. In addition, having the camera option on creates a separate camera subdirectory with the image sequence belonging to that camera. Before you start rendering, make sure to enable the camera mode for resolution and frame, so each camera can have their own resolution in starting and ending frame. This thing is a long image sequence with markers for each camera, different points of the timeline. So we select the camera here and make sure we enable camera mode on and the frame range from 0 to 149 for the kitchen camera. Continue on with top view, and you see I've already set up the camera mode on. I set up the frame to 151 to 299. Continue on with living room, frame start and ending, and then lastly the bedroom, and that has a range from 450 to 469. As long as you have the camera mode on, it'll automatically change the frame, and if you have changed the resolution, that can do that too. To summarize, so all this needed to create the raw output using render camera is just enable save, enable raw and camera, and then you set up each camera frame range resolution, and then you're ready to hit render animation. You can do it for the active camera or individual cameras with the selected, or you can do all the cameras in your scene. And you can also enable background rendering. It renders in a separate window, so you can continue working. The other feature slots looked for in my previous video that I have on camera mode and render camera. Let's now hit render animation on the background mode. And it'll have a separate window, and you can continue working on your project and scene. And you can see it started and it's taking about 5 seconds per frame to render with only 16 samples. Now let's look at the directory structure now that the render has finished. Scene 1, the root directory, and then every subdirectory has the camera name, and the camera name a raw subdirectory which has the raw image sequence. So you have kitchen raw, living room, top view. To enable the playback and Ultra Temporal Denoiser, we just select the playback checkbox. We can select animation or playback or image. Select a directory. You can go to scene 1, the raw, the first image of the kitchen. And when we turn on Viewport Rendering, you could do PostFX. You can see some of the tone that I adjusted. And then after that, I render image. You can save it. You can also use render camera and can render the image directly to a file. Make sure that when you render from playback, make sure that raw is disabled. Save to the format that you've already selected in the output. Change this to image. And then should use the active camera since you're rendering from an image sequence. Click render image. Go into the directory of kitchen and you'll have the we just render through render camera with a PostFX on it. The option for animation, select the mode animation. The path should be your root where all the different subdirectories of the cameras are saved. It will be scene 1. And then you'll have a subdirectory selection where you can also see all the different image streams from the different cameras that you've rendered previously. Select which one we want to work on, and you can instantly switch between all your camera renderings that you've done previously. You must have at least 3 images and they must be in sequence order, so it would automatically can apply the sequence into the timeline. And the sequence starts at 300 to 449 and automatically to that location, and the setup ready for playback. And notice that with this raw sequences you have the Ultra Temporal Denoiser available and vector blur. All these sequences can start playing immediately by just selecting and instantly going to the different subdirectories. Now let's look at what happens when an image sequence is not a multi-layer, that is a PNG. And this one, if you notice, I can play also a PNG sequence, but I will not have the Ultra Temporal Denoiser available or the vector blur. I can do adjustments for PostFX and render that sequence. Let's go back to our previous multi-layer EXR sequences. And we can start playing. It starts slower until it caches the stream. So it's playing right now around 10 to 12 frames per second while it's caching the video sequence. And now it goes back to close to 25. So it's playing back at every frame, which should be left to be the default. Here I switch to the kitchen scene. You need to stop the stream before you switch to another directory. Okay, so let's stop. You can also load an image sequence from a default blank scene. Playback. You can start playing any stream from any scene that you've had. The only issue is that when you load from a default scene, it will not have all your color management settings or output settings that you had for your scene or your camera specific settings. It gets lost. So now let's go back. We selected our kitchen scene. Turn some of the overlay settings here on the top. Turn off the floor, the axis. Just leave the text info. We can notice the animation looks smooth, but notice the amount of flicker on the glasses, bottle, the curtains. Enable the Ultra Temporal Denoiser. 3 settings. That's already becoming a lot more stable and a lot less flicker. You can go standard, high, there's still slightly some flicker, and then ultra, it cuts down the flicker almost completely. Toggle it back on. See how much flicker in the glasses the plants are. You toggle it back on. It becomes solid and stable. So there's a huge amount of flicker reduction and temporal artifacts get reduced. It's a little bit faster if I turn off the overlay settings completely. The vector motion is the amount of ghosting and motion artifacts that you get when you're stabilizing the scene. The motion color is rarely needed and should be off by default, and it can be combined or done separately. To visualize how the motion vectors are reducing the ghosting and temporal artifacts, enable the overlay motion mask, and you'll see black outlines at the areas where there is no stabilization for the reduction of the ghosting artifacts. But those areas will flicker and do not have stabilization. The goal is to have the threshold as high as possible. Right now it's set to 1. The threshold should be as high as possible, which means less black mask for best stabilization and flicker removal, as long as the ghosting or temporal artifacts is kept to a minimum. Turn off the viewport. You can turn off also the viewport fit zoom to show more detail. Stop here. Here's where you see a lot of the black overlay with a motion mask R, off, on. You see it's a little bit sharper and less duplicate image for ghosting up here when I enable the motion vector mask. Here at the end you can also see the modal ghosting reduction. Enable it, on, off. Use the sharpness on the chair is better. Less ghosting. Thin edges are on the glass and that could produce slight flickers. I would probably increase the several. The thin mask on those glasses get reduced. Do 2 probably would be a good. Now play it back. We can turn off now the overlay mask. You can see now that's completely almost flicker free. Color mask is doing. Let me turn it back on. You can turn vector off. It does too much. In this case, there'll be a lot more flicker using the color mask in a lot more black area. Definitely recommended for this thing to be off. And just leave the vector. Go over some of the settings. The compositor enable. This is the setting that allows you to view the compositor on the viewport. And that setting basically set to always. If you turn it off, no compositor. You lose all the playback capabilities in the viewport. Obviously that needs to be on. The other settings are zoom to view, so you can see the whole image in the viewport. The next one is hide all objects in the viewport. That's the critical for performance. Turn on info, so you can see, look at the frame rate. We're going about 20 FPS. If I off, it loads all the objects in the scene which are not needed for playback, since you're just playing from an image sequence. You see that frame rate drops to just 1.5 frames per second, so it's a dramatic difference in performance. For real-time playback, you definitely need to have this setting on, hiding objects. So now you see it goes right away back up to 20. The next one is set the compositor device to GPU. Setting is control here. That usually gives you the best performance. As you can see, it goes back and forth. Last one is the render samples. It sets the viewport render sample just to 1. There's no path tracing rendering going. That setting will revert back to whatever your setting was if you turn off playback. Turn off playback. Also, the objects on the scene get loaded back on. You get your setting and you get back to the path tracer. Turn back playback on. Load our kitchen scene. I've also rendered a non-multipass denoiser, so you can check the image quality. Turn off the zoom. There's more detail on the viewport. Select kitchen raw audio. This one is without multipass. Notice the image softer. Texture on the back of the chair, on the floor, the texture detail on the cushion of the chair, sharpness of the glass. Let me switch to multipass, which is, and right away you see this got texture detail, floor, you go back and forth. Blurry becomes on the back of the chair and it becomes softer. Go back to multipass. So at low sample rates, the regular denoiser makes the image noticeably softer and less detail. That's why the multipass is recommended. To enable PostFX, we just select the desired camera image sequence, click on PostFX. You can use camera mode due to the fact that the camera bindings are tied to timeline location. When we load a different image sequence, it has a different timeline frame number, and then the camera will switch automatically, and then we'll have camera mode effects, post effects for that sequence. So now we can change, for example, tone, make it brighter. We can change detail, so we get nice and crispier image with some of the color, bloom, work with another camera sequence, try the bedroom, enable camera mode, select it, a different type of tone mapping. We're good to have some bloom. And all of this detail can be done while the image stream is playing. Color. Now let's switch back to the kitchen scene, PostFX for the kitchen camera image sequence. Now we go back, check bedroom. We're now going to open the compositor. We can enable backdrop, compositor scene in the background. We can start playing this data much lower. Let's add a node into our playback system. Recommended to add it before KC PostFX. So we'll which is the one that's recommended. It doesn't have to be a split toning, it could be a third-party add-on PostFX. It can also be added after, just before the outputs, to make sure that you add it before the scale view, K-Cycles view, and connect to the group output. And now I'll put back the split toning mapping node behind the KC PostFX. I can change directories, the kitchen node, and I see it loads right where, but since we have PostFX Playback, the updates, as we can see, are very, very slow, or error keys. So you get the same functionality, harder to work with and much slower than the viewport. Make some adjustments here to make it more obvious. We go back to the 3D viewport. You can see that split toning node play it back at real time, with combining the PostFX additional split toning node that we just added. It plays at real time. You can render the animation by using the Control F12 render animation, or for better set up proper subdirectories, you can render cameras. Make sure you have only active, raw, disabled. What would be just an MPEG for video. Render animation. If you render the background to an MPEG-4 file, it will not show every individual update for every frame. It only updates when animation is completely finished. So now it's done. Or without the background, you'll be seeing updates, and I guess it's taking typically about half a second per frame for the most expensive setup, which is the Ultra mode in the K-Cycles Temporal Denoiser. It's completed. Take a look. Subdirectory under scene 1, kitchen, and there should be the kitchen. You can just click kitchen, a nice stable with PostFX, stabilizer, and everything together. Completed. Let's do a quick comparison with and without the Ultra Temporal Denoiser. So here's with the Ultra Denoiser turned off. Stop it, and let's do our render without the Ultra Temporal Denoiser so we can compare. Render animation. We're finished. Look at our video files. Denoiser completely off. Here it is. You notice the amount of flicker. Do it with the Ultra Denoiser on. As you can see, there's a huge difference in how stable it is. Here's another great scene from iMesh, outdoor garden scene. The K-Cycles Ultra Temporal Denoiser can work quite well in outdoor scenes. So I have enabled a playback, and let's play. And notice the amount of flicker on the tree leaves, grass. Turn on the Temporal Ultra Denoiser, and right away trees become very stable. Let's enable motion stabilization. Let's do the motion overlay record to adjust the proper thresholds. I can see a lot of black edges, overly masked edges on the trees. I like to reduce, so I probably would increase it to 3. There we go. So a lot of the edges on the mask are gone, and that would reduce the flicker on that area. So now that we have adjusted properly motion vectors, we can try to adjust some of the settings on the quality. So let me stop it here, and you can compare how the detail with or without Ultra Temporal Denoiser. On, off. The image detail and sharpness definitely can be improved in this scene. So let's go to PostFX, turn that on. Let's turn the tone and color, and I've already adjusted the detail. We can adjust some of the exposure, add some color, then we can compare off, on. So notice how much more detail. Of course, it's personal preference how much you want to enhance the detail. Play back, and let's have full size image without the detail enhancement, with it. So this image was done, took only about 5 seconds per frame, 60 render samples, and you get a very beautiful garden outdoor scene. Ultra Demonstrator off, the flicker is tremendous. Back on, completely gone without flicker. Here's a car scene that has both camera movement and object car motion. So here, the flicker is not too high, but you can mainly notice it in the reflection on the streets. It's got a bit of flickering on the reflections on the street and some of the buildings on the walls, the reflection. We're going to turn on now the Ultra Temporal Denoiser, Stable Modulation, and the mask. The motion vector mask following the object motion, in this case the car, and we're going to see how much ghosting happens in this image to adjust the proper threshold to get a clean image with good flicker reduction. We don't have the vector motion stabilization. See the amount of ghosting in temporal artifacts you get. With the vector motion on, the ghosting and temporal artifacts are completely reduced. So if I turn the threshold to 5, see there's some ghosting. Let's check the overlay mask from 5 to 1. See the mask covers more area to prevent the ghosting. And if you go to 0.1, get too much of the motion mask and you won't be able to get good flicker reduction. So I think the setting of 1 I think looks like a good compromise. So that's the way you can work and adjust the ideal settings for your motion vector stabilization. Now let's enable vector motion blur. You can see quite noticeable on the license plate, on or off. Well, you can adjust the samples for higher quality, but 32 seems to work quite well. And then the shutter, the higher, the more blur, the lower, the less amount of blur. I think 0.5 is a good compromise. And then you can play it all in real time to see if there's a good amount of vector blur that you have in your scene. And a really stable, the streets that have no flicker, so nice flicker reduction, a minimum amount of ghosting. Here's an interior choco fur scene that I converted from Cycles to EEVEE. K-Cycles' new EEVEE support for PostFX, render cameras, Playback, and Ultra Temporal Denoiser. It works exactly like in Cycles. EEVEE can have flickering in reflections, shadows, volumetrics, and others. The workflow for EEVEE is the same as in Cycles that I have previously shown. The PostFX also work per camera or globally. Render cameras, same functionality. Playback, the full Ultra Temporal Denoiser functionality. In this scene we have 4 cameras, main, side, terrace, table. Notice that all the cameras have the same frame start and ending. Select all the cameras, work with render cameras, do background, make sure we have raw on, camera subdirectories, render the animation. This rendering is taking about 6 to 7 seconds per frame. The other cameras should take 3 seconds. Enable playback, select proper directory, select the subdirectory for the camera. You look at the file camera main directory and each subdirectory for the raw data. Start playing camera main sequence and notice the flickering that we get on the faucet. Frame of the chairs, panels. Turn the Ultra Temporal Denoiser and the flickering from the faucet gone. Panels stop flickering, same thing as the frame of the metal frame of the chair. Now let's stop playing. Having the vector stabilization reduces the ghosting that you see on the light fixture and on the faucet. Turn it back on. Ghosting is gone, same thing as on the faucet. The threshold defaulted one is a good one to keep. Quite well stabilized. And I can turn Ultra Temporal Denoiser off and on, and the whole scene maintains the same sharpness. It's working quite well. Switch to side camera and just turn off. Look at the huge amount of flickering that you get on the oven and the microwave. So that's due to the shadowing on the light hitting the edges of the metallic oven and microwave. Turn on Ultra Temporal Denoiser. On the Ultra mode, almost completely removed in the highlight. Now let's switch to stairs. Ultra Temporal Denoiser off without almost no reflection, so it already doesn't really have minimum flicker to begin with. But even if I enable Ultra Temporal Denoiser, the quality of the image still maintains exactly the same. Also important, remember that when you change subdirectories to always stop the timeline and then the camera table. Temporal Denoiser off. The flicker here is mainly on the cables, light fixtures. They are flickering. Zoom out so we can see more clearly the flickering. Enable Ultra Temporal Denoiser on the Ultra mode. It's still slight flicker on the top. Take a look at the overlay motion mask. Slightly dark there, so we could probably increase it 1.5. It's good. And the black on the close-up, they are mainly to reduce the ghosting artifacts. Turn off the mask. Turn off the motion stabilization off. You see ghosting there. Vector on. The ghosting is gone. We've removed all the flicker from the cable-like feature and it looks stable. Go back to camera main, enable PostFX, and mapping, let's say we want to make brighter image. This scene doesn't have camera markers on the timeline to be able to change the camera automatically when loading a new image sequence. To change the camera scene automatically, we can use a new option called Change Scene from Path. We can just select it. This option looks at a camera name from the animation path and subdirectory to change the scene camera. The after camera can always be seen right next to the camera mode. This option works quite well when having PostFX per camera and you have the camera icon enabled. Camera, switch cameras automatically. You can have PostFX for this camera. We want to increase the detail. So let's go back to our camera main subdirectory. Let's work with PostFX per camera mode on. Let's adjust the settings. An afternoon scene. Let's switch side camera. The settings and adjust the tone. Let's make this maybe a early morning. We can add more detail. Off, on. If I go back to the camera mainstream, so use presets, sunset. Then we can make one for, we can do another one for morning. You can switch sunset, morning. So you can do your own presets. When I start over, click default, and it zeroes out all the PostFX. To render camera, and we have the setting output to MPEG-4. We can turn off background, and since if we're playing from a stream, we have to use the active only. Make sure the raw is off. We can keep the subdirectory camera, and now we can hit render animation. So you can see it's taking about 0.4 of a second per frame. It's finished. The same thing for the other streams. Side, click render animation. And also let's render one without the temporal denoiser enabled to compare the difference. Hit render animation. So let's go to our subdirectory and play the stabilize flicker free camera main. Now let's play without using the Ultra Temporal Denoiser. Look at the amount of flicker on this scene. Let's play the one with the Ultra Temporal Denoiser. Huge reduction in flickering. K-Cycles 5.0 is a great update with a new Playback, Ultra Temporal Denoiser, support for EEVEE, a new PostFX for Compositor, render camera raw mode, and more. The Ultra Temporal Denoiser can achieve smooth, flicker-free animation. Results important to remember to have a properly optimized scene with lighting and materials. Thanks for listening.